Physics, Chapter 18, Question number 1. Calculate the gravitational force of attraction between two objects separated by a distance of 1 centimeter and each having a mass of 100 grams. That is part A. Let's see how to do it. What is the equation that you need to use? So the force is equal to capital G, capital M, simple M, or M1, M2 divided by R squared. So this is the equation we need to use. And now we know the value of G, that is 6.67 into 10 to the power minus 11. I'm going to leave it as it is, as G itself, because this screen is a little smaller. So G multiplied by then M. So two objects separated by a distance of 1 centimeter and each having a mass of 100 grams. So 100 grams means we have to divide it by 1000. So then it is going to be 0.1 multiplied by 0.1 divided by R squared. R is 1 centimeter. So then it is going to be, once again we have to divide it by 100. Then it is 0.01. It has to be squared. So now we know the value of G. G is this 6.67 into 10 to the power minus 11 multiplied by 0.1 multiplied by 0.1 divided by 0.01 squared. And you will get your answer to be 6.67 multiplied by 10 to the power minus 9. And the units are going to be newtons because it's a force. I hope you have got this answer. Let's go to part B. Part B, two asteroids separated by a distance of 4 into 10 to the power 9 meters and each having a mass of 5 into 10 to the power 10 kilograms. So let's see how it can be done. So once again the force is equal to G. I will write M1, M2. It is the same thing, divided by R squared, same thing as G, capital M, simple M divided by R squared. So here once again I will write G as it is, as G itself, because the screen is small, but the value is 6.67 into 10 to the power minus 11. And then now these objects, two asteroids separated by a distance of 4 into 10 to the power minus 9 meters and each having a mass of 5 into 10 to the power 10 kilograms. So we have to take that value. Masses are the same. 5 into 10 to the power 10 5 into 10 to the power 10, and this has to be squared because it is M1 into M2. Each has a force of that. Then that has to be divided by, then what is the separation? 4 into 10 to the power 9 meters. That has to be squared. 4 into 10 to the power 9, and that has to be squared. So then you will get your answer to be 1 into 10 to the power minus 8 newtons. Let's go to part 3. A satellite of mass 1.4 into 10 to the power 4 kilograms orbiting the Earth at a distance of 6,800 kilometers from the Earth's center. The mass of the Earth is 6 into 10 to the power 24 kilograms. So the same equation we have to use. F equals G M upon R squared. Now G we will leave as it is. Then mass, if you take the mass of the satellite or the Earth to be capital M, the only reason why I took it to be capital M is because it's bigger. Other than that, there is no other reason. You can choose anything. Multiplied by then the satellite was 1.4 into 10 to the power 4. Its mass was 1.4 into 10 to the power 4. I will write it here, 1.4 into 10 to the power 4. And this total thing needs to be divided by the separation. The separation is 6.8 into 10 to the power 6, and that has to be squared. They have given 6,800 kilometers, so that has to be converted into meters. 6,800 when it is converted into meters, you get 6.8 into 10 to the power 6. I hope you understood that. So when you divide this, you will get 1.2 into 10 to the power 5 newtons. So that is the answer for part C. Let's go to question number 2. Estimate the gravitational force of attraction between two people sitting side by side on a park bench. How does this force compare with the gravitational force exerted on each of them by the Earth, that is their weight? So we have to estimate. You have to estimate means you can take a general value of weight. So if you take the average weight of each person to be let's say 70 kilograms and 70 kilograms, and if you take the separation to be 0.5 meters, you have to once again use the same thing, same equation. F equals G capital M simple M divided by R squared. G you know 6.67 into 10 to the power minus 11. G multiplied by 70 into 70 divided by R squared is 0.5 squared. And if you take these values, if you can take, instead of 70 you can take 80. It doesn't really matter. You have to get you have to do the calculation properly after that. So then you will get the value to be 1.3 into 10 to the power minus 6 newtons. So so this is the final calculation. They are asking another question. How does this force compare with the gravitational force exerted on each of them by the Earth, that is their weight? So the weight is the weight of these people, because their mass is 70 kilograms, they would have a weight of 700 newtons, right? So 700 newtons is the weight that they would have, and that against 1.3 into 10 to the power minus 6 newtons is the attraction that they have. So their mutual attraction is very much less compared to the force of attraction by the Earth towards the center of the Earth. So that is your answer. I hope you understood. If you have any further questions, please ask them.